Okay, we've been talking about heat and thermal physics for a while now. Time to talk about how heat can be transferred from one place to another place. So, heat transfer can occur in several ways. This video is mostly about conduction, but we're going to mention the other forms as well just to get things kicked off. So here goes. This is just a quick little way of illustrating the three different kinds of heat transfer. This picture right here. So what we have there is a fire. It's burning probably in a patch of forest, or possibly that's somebody's fire pit. In any case, we've got some logs here. They're burning. Fire. Lots of fire. There's some smoke here too. Alright, so what's going on? Well, any kind of heat transfer by direct contact with the heat source is called conduction. So this part down here, this is getting heated up by conduction because these things are all touching the flames, so they are directly getting heated by conduction, by physical contact. Okay, convection, we'll just define really briefly. Convection is when heat is transferred by the movement of air or liquid. So hot air or hot liquid is going to rise, go up. So if it's hotter than the surroundings, then it goes up. True for liquids, true for gases, not true for solids. So this is where the convection is happening above the fire. The heat from the fire is being transferred up by the hot air that is rising. All right. Off to the side here, actually all around, in all directions, we have radiation happening, but the only way that heat can travel sideways in the air is by radiation. So the radiation doesn't actually travel by contact with air particles. Convection requires air particles to be hot and they rise. Conduction requires molecules or atoms to be hot and touching each other. Radiation actually happens by infrared electromagnetic radiation, which doesn't require contact with anything, actually. It can pass through a vacuum. So that goes out in all directions. All right, so that's radiation. So the only way that you can get hot standing near a fire beside it is by the radiation that's coming off from the fire. Okay? All right, so conduction specifically. All right, so as we were saying, conduction requires a physical contact between two things. They can be solids, liquids, or gases, but usually we talk about conduction in solids, and the result is that heat is transferred by that contact. So here's a couple of cases where you can see heat being transferred directly by contact. There's hot liquid in here. There's a spoon in there. It's in contact with the hot liquid, so if the end of the spoon up here gets hot, that's because of conduction. All right, same thing there. If the coffee cup itself on the outside gets hot, that's also because of conduction. Guess what? That's why we have these little handles. Then we can hold the handle, which is less likely to get hot because it doesn't have as much surface in contact with the liquid. All right, here we have a little baby. He's so cute, he or she. And the hand of their probably father, looks like. So there's heat conduction going on between the baby's head and the father's hand, right? They're in contact, they're physically in contact, so they're going to transfer heat between them. If the baby is maybe cold, then the father's hand is maybe warm, then he's warming up the baby's face with his hand. All right, and then we've got a pot on a stove. If the stove is turned on, then this metal here gets really, really hot. It's in contact with the metal pan, so the contact there allows heat to be transferred and the heat goes into the pan by conduction. All right, metal is a good conductor. Incidentally, why do you think the handle is made out of plastic? Plastic is a bad conductor. All right, so you don't want the heat conducting out from the pot to the handle and then you grab it and burn your hand. So you want something that is a poor conductor of heat for the handle. Metal is a good conductor of heat. Okay, so here is an example of a demonstration that you might see. In fact, we might do this in class. Basically, you've got 4 different metals here. 1, 2, 3, 4 different metal bars made of 4 different metals, and you want to find out which one is the best conductor. So you'd need a source of heat, and the source of heat would need to be heating all of these bars evenly at this end. So the heat source is heating up this end of the bars. You've got these different metal bars, and then you've got some metal ball bearings or something like that stuck to the bars with wax. All right, so these things are all stuck on there by wax. They're held on there just fine right now, but if that wax gets hot, what's going to happen? The wax melts. If the wax melts, the ball falls off. So you can sit here and watch over time. The heat is going to be conducted from this hot end over to the cool end, right? And it'll get hotter and hotter and hotter and hotter all along the bars, hotter and hotter. Whichever one is the best conductor will get hot at the end the fastest. So whichever one gets hot at the end the fastest is the best conductor. How would you find that out? Well, you'll watch the balls drop off. First this one, then that one, then this one, then that one, then finally that one. And whichever of these bars loses all 5 balls first is the best conductor. And whichever one is the slowest to lose all of the 5 balls is the worst conductor. All right? So a good conductor of heat basically transfers the heat very efficiently and very quickly. Metals are usually good conductors, although some metals are better than others at conducting heat. Poor conductors are things like plastic or wood or, basically those sorts of things. You know from experience what's probably a good conductor and a bad conductor. Clothing, cotton, rubber, those kinds of things are bad conductors. Things that are good conductors are metals, and actually glass somewhat is a good conductor, but kind of depends. Anyways, sometimes glass is used for cooking, right, and it does get hot. Sometimes glass is used for other purposes, like in windows. Yeah, it depends. It depends. Glass is a tough one to say whether it's a good conductor or a bad conductor. Anyway, the whole point is, if it transfers heat quickly from one place to another, it's a good conductor. I think glass is generally considered to be not that great of a conductor. In any case, moving on. All right, here are some common everyday examples of heat conduction. So this guy is running or walking barefoot on asphalt. Asphalt's black. We'll learn more about this when we talk about radiation, but black things absorb heat the most efficiently of any color. So black things are going to get really hot when there is sun shining on them. All right, so running barefoot on black asphalt, if it's a hot day, is a really bad idea. You can actually burn your feet really badly that way. So that's because of conduction. Because of your feet in direct contact with the hot surface, then heat is transferred from the surface into your foot, because the surface is hotter than your foot is. On the flip side, if you're running on asphalt barefoot when it's cold, and the asphalt is colder than your feet, then heat will transfer out from your feet into the asphalt. Here's another example. This guy's holding some shaved ice in his hand. What do you think's happening? The ice is definitely colder than his hand. So his hand, heat is going from his hand into the ice to melt it, and that's going to make his hand really, really cold. All right, here we have a pan that's been used to fry up some veggies, it looks like. And you'll notice, what's the handle made out of? Wood. The reason for that, of course, is conduction. You want a substance on the handle that is not a good conductor, so that the heat from the pan stays at the pan and doesn't come out the handle and burn your hand. And one more example. Here we have a man using an iron. It looks like a sort of an old style of iron, but he's using a hot iron to press this shirt, so the heat is transferred by conduction from the hot iron made of metal into the shirt, and that lets you iron out and smooth out those nasty wrinkles and make the shirt look all nice and crisp to wear. All right, you'll also notice the handle of this iron. What's that made out of? Certainly not metal. That looks like wood in fact. So again, making use of good and bad conductors to accomplish the heat transfer that you want to occur. All right, great. That's all I've got for you for this one. Check out the next video to learn about convection.